Hello everyone, today we are starting our lesson on difference of means. So this is very similar to difference of proportions except for the fact that now that we're dealing with means, that means numeric data. So we're looking at numeric data now. So this is very, very similar to day one of proportions, but numeric data. So let's read this setup here. Last year, a high school had 30 students take the AP statistics exam. We were informed later that the College Board gave 2 forms of the exam, which were randomly assigned to the students. Here are the results. So here's the scores for Form A, and here's the scores for Form B. Right here it says calculate the mean score for Form A and the mean score for Form B. So what we're going to do is take a second. We're going to pause. We're going to put Form A data into list 1 of your calculator and Form B data into list 2 of your calculator. You're going to run the one variable stats on these to find those average scores. So go ahead and pause the video and do that now. Okay, so you should have gotten that the mean score for Form A is 4.2 and the mean score for Form B is 4. What is the difference of means? And you can see how we're supposed to subtract A minus B here. Let's go ahead and find that. So 4.2 minus 4, that difference is 0.2. Right here it says, assume the 2 forms are the same difficulty. So if Doug scored a 5 on Form A, he would also score a 5 on Form B. In other words, Doug is a 5 no matter what form he's randomly assigned. They're still going to score that same score. The 30 AP scores, so this is something that we would normally do in class together, this part. But since I'm not here today, we're going to just kind of show what would happen had we done it together with a little simulation. So what we would do is I would give you a distribution of all of these scores on a piece of paper. You would mix them up, randomly assign half of them to Form A, half of them to Form B, and then take those new averages. So an example of that could be once we mix them all up, you could get an average of like 3.95 on Form A and 4.25 on Form B, just depending on how these values fell when we mixed them up. And the mean difference would be negative 0.30. This would be one example of a possible score, difference of scores. Then we would go ahead and put that number up here on the dot, or this on the dot plot. So what I'm going to do is pause this video and I'm going to go ahead and sketch a difference of the mean scores from a simulation of 21 random values. So I'm going to go ahead and put that up here and then you can sketch that out also. And we'll use that to answer these 2 bottom questions. Okie dokie, so by simulation or by chance only, here is the distribution in the difference of scores for Form A and Form B. So this is what that distribution looks like for 21 simulated scores, differences of scores. So what we're trying to see is it rare to get a difference of 0.2 or higher? So the high school had a difference of mean scores of 0.2. Is this outcome surprising if we assume both forms are equally as difficult? Well, let's go look. So what we would say is, all right, 0.2 is right here. What proportion of values is equal to or greater than 0.2, which is the difference we found above? So we can look at this, and out of 21 scores, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 21 are greater than or equal to 0.2. This is 0.38%. So it's asking us, this question is asking us, is this outcome surprising if we assume both forms are exactly the same difficulty? And the answer is no. So I'm going to move this a little bit. No. Assuming the forms are the same difficulty, there is a 38% chance, or 38% probability, let's say, of getting a difference of sample means. Of 0.3, I'm sorry, why did I put 0.38? Of 0.2 or higher, purely by chance. So down here it says, based on the simulation, do we have convincing evidence that one form of the exam is harder than the other? Well, no, because 0.38 is our simulated like p-value. And if we compare that 0.38 to our basic alpha value of 0.05, that is greater than, so we would fail to reject that null. So no, it's not surprising to us. This outcome is not necessarily rare because we see that this happens frequently. It happens frequently that this score can occur, or this difference in scores can occur. So no, this result is not surprising. Since it's more than 5%. So we don't have convincing evidence against the null, which is that one form is harder. Okay, let's go to the back to get some examples and some definitions. So today's lesson is very similar to what we have already learned, except for the fact that we're dealing with numeric data now, and we're dealing with difference in means. X bar sub 1 minus x bar sub 2 is those difference in means. Let's talk about the shape. We already know about this. The shape of the distribution is approximately normal. If both samples meet the normality condition. And we've done this many, many times, okay? We remember this. So condition number 1 is either that both populations are stated as normal. Option number 2 for normality, N1 is greater than or equal to 30, and so therefore N2 is also greater than or equal to 30. And by the central limit theorem, the distributions are approximately normal. And if that doesn't even work, option 3, we look at those normality plots, and this is only if we have raw data. And they both need to be approximately linear. So the distributions are approximately normal. So just like with proportions, we just check our normality condition to help us know what the shape is. And we have our regular options 1, 2, and 3, but they just need to be met for both samples, both populations. Okay, the center is just like what we know to be true for sampling distributions of means, except for now we're just using the difference of means. The center of the distribution is just equal to the two parameters subtracting each other. And the standard deviation formula in this case is equal to the square root sigma sub 1 squared over n1 plus sigma sub 2 squared over n2. So I'm going to go ahead and let you guys try the U-try problems. They're going to walk you through identifying the shape, center, and spread of a difference in means sampling distribution. And when you're ready, unpause the video and check your answers. Okay, so we notice that the distributions are already stated as normal above. So that is helpful with us when we're going to find out about the shape. They're both stated as normal. Below, it asks us to find the mean, and we are given the mean for men and for women. So we can just go ahead and subtract those. to find the mean of the sampling distribution, the differences of means, which is 4.8. And same thing, the standard deviations are provided here. Sigma sub m and sigma sub w are provided, so we can just plug them directly into the formula to find the standard deviation for the difference of means. Hopefully you see some similarities between this and what we have been learning not only this unit, but for the last couple units. We're going to work on confidence intervals as well as tests with difference of means coming up. Bye.